Our sun isn't standing still. It's orbiting the Milky Way at about 220 kilometers per second, completing one full circuit every 230 million years. In this video, we'll break down what that motion means, how scientists measure it, where the solar system has traveled, and how those journeys line up with major chapters in Earth's history. So what's a galactic year? One lap equals 225 to 250 million Earth years. Astronomers call that a galactic year, or cosmic year. Since the sun's birth, it has finished about 20 laps. One lap ago, dinosaurs were just getting comfy in the late Triassic. 10 laps ago, Earth's atmosphere was undergoing the Great Oxidation Event. A single human life is to a galactic year what a heartbeat is to a day, a mere blip. How does this route look like? The sun sits roughly 27,000 light years from the Milky Way center, in a calmer stretch of the disk well outside the dense, high-energy region surrounding the supermassive black hole. Our solar system moves at about 220 kilometers per second, roughly 0.07% light speed. Yet the Milky Way is so large that completing one orbit still takes around 230 million years. The orbital route is almost circular, with only a 10% squish. Right now, we're near the orbit's closest point. In 15 million years, we'll be 0.5% near the core, and 100 million years after that about 14% farther out. The tilt plane of our solar system is tilted about 60 degrees to the galaxy's disk. So as we zoom around, the planets are rolling sideways relative to the Milky Way. The up and down bob. The sun doesn't hug the midplane. It bobs through it like a carousel horse. The sun is presumed to be about 50 to 75 light years above the Milky Way's midplane and drifting farther north. The oscillation period crosses the midplane roughly every 30 million years and reaches a peak 230 to 300 light years above it before falling back. Earlier theories linked those crossings to mass extinctions via comet showers, but the data now say probably coincidence. Our galaxy neighborhood. The solar system sits in the Orion, Cygnus spur, a comparatively quiet lane between the Sagittarius, Carina, and Perseus spiral arms, and over hundreds of millions of years, it slowly drifts into and out of those denser star-forming regions. The solar system currently resides in the local bubble, a low-density, low-dust cavity of hot gas carved out by ancient supernovae. Gliese 710, an orange dwarf star, is projected to pass within about 1 light-year of the sun in roughly 1.3 million years. The flyby may jostle Oort cloud comets, but poses no direct threat to Earth. How do we know all of this? For more than a century, astronomers have used Doppler spectroscopy to measure tiny shifts in stellar spectra to work out the sun's speed and the Milky Way's rotation, a method refined by Jan Oort. Another helpful instrument is ESA's Gaia satellite is mapping 1.8 billion stars. In 2020, its data revealed the solar system's centripetal acceleration, confirming the 220 kilometers per second. Large-scale M-body simulations, computational models that include stars, gas, and dark matter, recreate the Milky Way structure and track how orbits evolve over billions of years. Clues such as meteorite chemistry, mapped star streams, and the absence of nearby fast-moving stars all indicate the sun follows a steady, almost circular orbit. Earth story in galactic laps. Key moments in Earth's history told in galactic laps. 1/2 lap ago, 115 million years, giant sauropods strode across a splitting Pangea. 1 lap ago, 230 million years, the earliest true dinosaurs emerged. 4 laps ago, 900 million years, multicellular life began to flourish. 8 laps ago, 1.8 billion years, a surge of oxygen dramatically reshaped Earth's atmosphere. 20 laps ago, for 0.6 billion years, the solar system formed and the sun set off on its very first circuit of the Milky Way. Framing it this way makes deep time tangible. Instead of 450 million years ago, you can say 2 galactic orbits back. Where the road leads, the sun's only halfway through its 10 billion year main sequence run. So in about 40 to 50 galactic laps total, before it swells into a red giant. Before that happens, in 4 to 5 billion years, the Milky Way and Andromeda will merge. By then, the sun should be entering its red giant phase, and Earth is sadly expected to be uninhabitable. For now, we're safely coasting the galactic suburbs, shielded from the worst radiation storms near the core, and enriched with just enough heavy elements for life. Closing thought. The next time you gaze at a sunset, remember, our star isn't just drifting overhead. It's moving at an incredible pace around our spiral galaxy, bobbing, weaving, and capturing Earth's epic saga one cosmic lap at a time. So if you enjoyed this video, click the like button, share this video, or subscribe for more interesting stuff about our cosmos.